We now consider 3 points P, Q, and R, and the figure that we get by, well, it's a parallelepiped, a parallelogram along any two faces and so forth. Let's not worry about the definition of a parallelepiped. In any point, the triangle PQR is clearly a triangle, and that triangle lies within a plane in 3 dimensions. If I sketch the vector from P to Q, the vector PQ, and the vector from P to R, the vector PR, and the vector from Q to R, QR, so I've got PQ, don't really have a lot of room for that arrow, QR, and PR, then we see that those 3 vectors do form a triangle. So we can say that the vectors PQ, PR, and QR can form a triangle. Another thing we can say is that PQ plus QR equals PR. And we can say other things that, or if we want, we can say that PR minus QR equals PQ. If we go along PR and then reverse along QR, we get PQ. Now, we ask some questions. Is the triangle formed by PQ and R a right triangle? Well, it's so if the triangle satisfies the Pythagorean theorem. So if and only if the Pythagorean theorem holds. Now, looking at the orientation of this, we can't necessarily tell which of these would be the hypotenuse, which would be the legs, but we can find the magnitude of PQ, magnitude of PR, and the magnitude of QR, and check. Whichever of these two are least, if their squares add up to the square of the other, then we have a right triangle. Now, we can also ask the question, what are the angles between these various vectors?